All right, guys. Looks like we are live according to everything I got here. So we are starting Unit 6 today, and this is the first unit that we're really going to do this 100% online. And it's probably, well, it's not the first unit I would choose to do this. So it's extremely math intensive, and you're going to need just about all the skills that we've learned so far to do okay in this unit. So it's going to be all word problems, okay? And we're going to have to baby step it, of course. We're going to learn some conversion factors and how to use them, and then start seeing more difficult questions as we push through the unit, okay? So when I say conversion factors, you got to think back to Unit 3 when we were doing like the all the stuff converting from meters to millimeters and things like that, converting units with conversion factors. So I'm going to do a very quick recap of that stuff, and then we'll get back into talking about what this unit's all about. So let's do this thing. All right. So here's excuse me. So if you remember the conversion factors, they were like you had, what was it? 1 kilo base is equal to 1,000 of those. So I could put meter, I could put liter, and you get the idea. All right, 100 centi blanks is equal to 1 of those blanks. Okay, does this sound familiar at all? I hope it does. All right, this is something that we learned back in Unit 3. Then the final one was 1,000 milli blanks is equal to 1 blank. All right, remember that? Does that sound familiar? For those of you who are actually in this this video at the moment, please let me know that that is familiar, and let me know how the audio sounds. Excuse me. And this way I have an idea of who's watching. All right. Please check in with me. And I want to thank you guys for continuing with the attendance. Every day you guys are checking in, and I'm keeping track of that, and I thank you for actually following through. Okay, so it looks like we have 8 people that are watching at the moment, and we have had 11 people sign in for attendance today. So sounds about right. All right. Okay, thank you, Matt, for actually confirming that somebody's here. Okay, so the audio seems to be good. Conversion factors are basically the basis of this whole thing. Now, let's move forward with new conversion factors, okay? This is going to be, thank you, Annalie. This is going to be strange, but if you stay with me, it's going to make sense, all right? So we're going to keep track of this. This idea is going to be used. So let's move up. Now, there's a thing called a mole. Okay? The mole is a very, very useful unit. Okay? It's extremely useful and powerful in chemistry and even biology. When you start getting into like biochemistry stuff, probably in college, this is going to be used a lot. Okay? You can have millimoles and you have kilimoles. So this is a base just like a gram or a liter or a meter would be. You could put prefixes in front of this as well. Now, the reason why the mole is so useful is because it actually connects 3 different ideas together. Okay? You can have the idea of a mass connected with the mole. You can have, and this will demand some sort of explanation, representative particles, okay, or the volume of a gas. So those 3 ideas, this makes up the mole roadmap, okay? Excuse me. In the PowerPoints that I sent out at the beginning of the unit, there was in Unit 7, one of the slides is a much better form of this mole roadmap, and we will explain all of this in detail. We're going to start just by talking about how mole is related to mass, okay? So we're going to talk about this today. We'll probably talk about this tomorrow, and then next week we'll get into this stuff here. All the while, there will be random assignments on Google Classroom that you're going to have to try, and we'll give you the answers for that and some tips along the way. Okay? So let's talk about how the mass and the mole is going to be related. Now, what I need to do is bring up a periodic table. Let's see here. So remember this periodic table? Okay, hopefully you have one there. Let's look at some random elements. So if we zoom in, I can't really zoom in. Hopefully you have a periodic table there. I'm trying to figure out how to do this from afar. Let's do it this way. Let's switch to this, okay? So you got a periodic table down on the one corner, and then me in the other corner. So let's look at, let's say carbon. Okay, in previous units, we learned about the number of protons and electrons and all that stuff. But if you look at the periodic table, okay, there's a mass listed. And we learned that it was the average atomic mass. So for carbon, it's 12.011. Okay, I hope I got that right. Do I have a periodic table here? Thought I had a periodic table that I could refer to. I guess I don't. But anyway, so carbon is 12.011. All right? Now, let's say I want 1 mole of carbon. Okay? Now, you don't know what a mole is. You've never talked about this before. But what I can tell you is that 1 mole of carbon has a mass of 12.001 or 12.011 grams. That's how moles and mass are related. So oxygen, 1 mole of oxygen. Keep in mind, oxygen is O2, right? It's one of your diatomics. So oxygen would be 2 times 15.999. Now, I got that 15.999 from the periodic table. So you're looking, and I'm just rounding here, you're looking at 1 mole of oxygen to be about 32 grams. Okay? So anytime you have an atom or a compound, you would just add up its masses from the periodic table, and that would be the mass of 1 mole. So in labs, when you're working in the lab, and say you have a lab partner or what have you, and you need to do an experiment, this will make more sense in another unit, but say you need 4 moles of something. There's no way to really measure a mole, but you can measure grams. Does that make sense? You have a scale, you can measure grams, and then do this quick conversion to get to moles from grams. So let's go to another piece of this paper here, okay? All right, let's say I have a question, all right? How many grams are in 4.5 moles of helium? It's a very reasonable question, okay? Now, you're going to convert this, okay? You're going to need the periodic table. You're going to need the mole roadmap that I drew out a moment ago. All that is going to help this make sense. So you always start with what you know. I hope that sounds familiar from previous units. So you start with what you know. In this case, 4.5 moles. And I want to know grams. So I have to make a note that this is for helium. I'm going to multiply it, and I'm going to cancel out moles. Okay? It's always going to be 1 mole. All right, at least for now. 1 mole would equal how many grams of helium? Well, to do that, I have to go to the periodic table, and I find the mass. And helium, if I look at the periodic table here, maybe you can see it a little better than I can, but it looks like, let me make it bigger for me. It looks like the mass of helium is not even on this periodic table. Wow, that was such a drag. All right, so on your periodic table, hopefully you have one there, and I'll find a better one to be using in these videos for next time, for tomorrow. The mass of helium is about 4. Now, I'm rounding, so that's not something you want to do. You don't want to round, all right? So 1 mole of helium is equal to 4 grams of helium, okay? I got this from the periodic table. Now you got to do the math because you canceled out moles and you're left with grams. That should answer the question. 4.5 times 4. Now let's do that in your heads. No calculators. Let's see if I can do it. 4 times 5 is 20. Carry the 2, so it comes out to be 0.0. 4 times 4 is 16. With the 2, it's 18. So 2 sig figs, I need 18 grams. Does that make sense? Let me know if you guys are following along. And, yeah. So 1 mole is equal to the number of grams from the periodic table. Or in other words, 1 mole has a mass equal to the atomic mass in grams. Okay? We're going to call that the gram atomic mass, or the molar mass. You might see this worded a couple different ways. So from the top, let's do this again. So I have a few of these memorized. I really thought I had a periodic table here. Let me check again. I got all these papers from just doing all these lessons. I just got done doing one for my other class, and yeah, here it is. Okay, so I have this periodic table here. This is one that we were using in class. Well, it's not exactly the same, but it's close enough. So on this periodic table that I have the atomic number and mass, and we'll be referring to this as we go. You should have something like this yourself. If you don't, then just get one off the internet, right? Google periodic table or printable periodic table, and you'll find plenty. Print it out, and you have it there, or you can save it as a tab, whatever you got to do. So the molar mass, okay? Let's go back up here. Molar mass, all that means is 1 mole is equal to the mass from periodic table in grams. Now you can do that for, not ing, but in grams. Now you can do that for elements, or you can do it for compounds too. So we'll do a couple more elements. Like for instance, I'm just looking at the table here. 1 mole of lithium would equal 6.941 grams of lithium. So depending on what you're doing in the lab, if you need 1 mole, you would go to the scale and you would mass out exactly as best as you could, 6.941 grams. Now let's say you needed 2 moles. You would just do that twice. Right? Now let's say you needed like 3.8, because we just did something like that, 3.8, just some random number. So 3.8 moles of lithium. Now you don't know how many grams that is, but you can convert it. So get rid of moles, go to grams. 1 mole. It's always 1 mole, at least for now. And each mole is 6.941. So remember, the top's got to equal the bottom for this to work. And then you would just multiply this by that, do your sig figs to 2, and then that's how many grams you need on the scale. Okay? I need to get a calculator for my office, so for the moment I don't. But that's all you would do. 3.8 times 6.941 divided by 1, round it to 2 sig figs. That would be the mass you need on the scale to equal the 3.8 moles you need for the experiment. I hope that works. I hope that's okay with you guys so far. So you could do that with any element. We did carbon, we did oxygen, we did lithium. We do something crazy like lead is 207.2. Okay? AJ gave me the answer, 26. Thank you. I appreciate that. All right. That makes sense because 7 times 3. Yep, that looks good to me. Okay? Excuse me. So you would need 26 grams of lithium to equal that 3.8 moles of lithium. Anyway, any element, you just go to the periodic table, find its mass, put it in grams, just say that many grams, and that's how much the molar mass is, or the mass of 1 mole. Now, you can do that with compounds, too. So let's do an easier one, like carbon monoxide, okay? all you do is add them up. One carbon is 12.011. Oxygen is 15.999. You add those up together, and that's the mass of carbon monoxide. Now, some people are going to ask for sig figs. The problem is there's really no good rule here because each periodic table is different. That's the first problem. So you might have a different mass with more decimal places than other periodic tables. And also, you have to treat these as if they're defined quantities. So it's very difficult to come up with a sig fig rule, okay? So what we're going to do, let's make our own rule. Just give me 3 places. So you're going to add these up, and you're going to give me 3 places, all right? Whatever that adds up to. It gives 1, 2, 3 after the decimal. So you're looking at like probably 27 or 28, give or take what's going on there. All right, you could do CO2. You just add them up. I have 2 oxygens in this case. And that would be the mass. And you give me 3 places after the decimal. So you got the molar mass of compounds. You have the molar mass of atoms. You can do the molar mass of ions, like phosphate. You just add them up, PO4, whatever. Get all the mass together. So that's that, okay? That's the molar mass and how moles are related to the mass. Are we good? All right, let me know if I got some confirmation here. Matt said that it made sense a few minutes ago. I want to make sure that the compounds are good with you guys. And what I'm going to do is I'm going to find a worksheet online, and I'm going to attach that to the Google Classroom, the announcement for this video. So you watch this video, then you try the assignment. It's not going to be very difficult. It's not even going to be something that you can answer through the Google Classroom. It's going to be like a PDF that I find online. And then tomorrow's video, we will start with this, with that assignment. I'll give you some of the answers, and we go from there. So everybody good? All right, give me some kind of confirmation that we're okay. I'm going to bring this to a close in a few moments, and I'm kind of stalling. This stuff isn't all that hard. It's a little tricky, but so far you've only learned one conversion factor, and that was, oh man, I already lost my mole roadmap. I just had it here a minute ago. Here we go. So for the moles, we learned that a mole is related to mass, a thing called representative particles, and the volume of a gas. But so far we've only done this one leg. Now you can go back and forth, okay? So for instance, I didn't do this, so this is a good one to follow up with the end of the class. So let's say I had, I'm just making this up, 12 moles of chlorine, and I want to know how many grams that equals. All right, so you start with what you know, 12 moles. Actually, that is exactly what we were doing. Let's say I had, I'm struggling this morning. Let's say we had, I don't know, 42 grams of Cl2. All right, Cl2 because it's a diatomic. Okay, so you start with what you know, 42 grams. Get rid of grams, go to moles. You need to figure out how many grams are in a Cl2. Now, each chlorine's about 35, so I'm just going to round it to 70. Make sure that you're doubling it if it's one of those diatomics. And then all you do is the math. 42 times 1 divided by 70. Grams cancel out. Your answer is going to be in moles. Give me 2 sig figs, and you're done. It's that straightforward of a conversion factor. Now, this is a very simple skill, but it will compound into more difficult questions as we move forward. So we're going to kind of baby step these conversion factors together, all surrounding moles, and then we're going to build up your skills and do more complicated questions and put these things together in a much more, complicated question. So we're going to stop here. Okay, I haven't gotten much feedback in the past few minutes, so I'm going to leave it there. We went through moles to mass, mass to moles. We'll leave it there. Check Google Classroom for a worksheet I need you to try, and tomorrow morning at 10 a.m. we'll be doing another live stream, starting with the answers of that worksheet. Maybe not all of them, maybe a couple of them, and then we'll move on to talking about representative particles. All right, guys. Cool. Thanks for checking in. Thanks for doing attendance. Thanks for watching this video. And just keep doing what you got to be doing. All right? I'll talk to you again tomorrow. Thanks.